I'm the course instructor for this MOOCs course on natural gas engineering. So today we are having the first live session of this semester, like 2025 batch. I'll be live till I'm getting the questions. So I encourage all of you who are joining uh, this live session, please keep asking the questions. We can keep running this session at least for 1 hour duration that is specified by the NPTEL team. So I checked the doc file where I did not find any question, but I hope like you are going to ask the questions on YouTube chat room through. So I'll be here and answer the questions. Thank you. I hope like you will ask the question. Meanwhile, what I can do, I can quickly revise the course content of natural gas engineering. So this MOOCs course was designed for 20 hours, 8 weeks plan. So all the lectures and the week plans are laid out here. So in the natural gas engineering course, we started week 1 with the introduction to natural gas, where we discuss about the origin of the natural gas, what are the uses of the natural gas, how important this natural gas could be in the future. And then in week 2, we discuss the properties estimation of the natural gas. Natural gas is a complex mixture of hydrocarbon and non-hydrocarbon gases. The properties of the mixture, that is natural gas, varies depending on the composition, and a lot of complex expressions are there to estimate the basic properties like the viscosity, uh, compressibility factor, even the density, that is record the compressibility factor, and so a good amount of the time was spent in week 2 to estimate the properties of the natural gas. And then, of course, this natural gas is found in the reservoir domain underneath the surface at several thousand feet depth. So the rock properties and the effect of the pressure on the rock properties was estimated in week 2. So a lot of the method to understand the variation in porosity, permeability, how to estimate porosity and permeability, and other rock fluid interaction properties were discussed in week 2. After that, in week 3, we discussed the inflow performance relationship in detail. So if we see, this is the diagram that is showing the conventional production system of both oil and gas. Let's consider for this case, it is the gas well, where we are having the reservoir domain underneath the surface at a several thousand depth. And here in this domain, let's say predominantly it is a gas. Oil and water will also be associated, but as we are discussing the case of the natural gas production, let's say it is the gas that is in the reservoir domain. So the mathematical equation those describe how the flow of the natural gas happening in this porous permeable region at a very high pressure is called IPR, inflow performance relation, that we discuss in week 3. And using this IPR equation, we can do the well testing analysis that was also covered in week 3 lectures. When this natural gas from the reservoir domain reach to the production well, where the pressure is PWF, from this PWF to the surface, the natural gas just transported through a pipeline vertically against the gravity, and very high pressure is required to overcome this gravity and bring the natural gas to the surface. So the equation that is giving the relationship between the flow rate and then the pressure drawdown from PWF to PHF. PHF is the pressure at the wellhead, is established using the energy balance equation, and the resultant equation is called the WPR or Balfour performance relationship. Similar analysis was done for the third component of this production system, that is this wellhead Christmas tree, where a choke kind of the device is installed that regulate the flow or control the flow. So the relationship between the pressure drawdown across this choke device and then the flow rate relationship is established, that we call CPR, choke performance relationship. Now we are having the 3 places where the pressure is defined: PWF at the bottom, PHF at the surface, and then the pressure at the downstream side after the wellhead. The pressure continuity concept was established, that's called the nodal analysis, that we discuss in week 4, how the unknown parameter in these 3 set of the equation, IPR, WPR, and CPR, could use the pressure continuity concept and eliminate the number of unknowns by 1 number or 2 number when we are establishing the pressure continuity relationship. Once the natural gas produced to the surface, the first equipment it needs is the separator. Separate the gas along from the liquid substance, that could be oil and gas. And now the natural gas that is separated at the separator on the surface needs to go through certain processing unit before it is sent to the consumer. So the processing is done to refine or to purify the natural gas, as well as to extract the more valuable compound like the LPG, that is having the more value than the methane gas. So that is also extracted at the sometimes at the surface facility itself and bottled separately to send it to domestic applications. Similarly, other valuable fraction can also be extracted. But before sending this natural gas to the consumer, it needs to go through the processing at the surface itself. For example, the dehydration process to remove the moisture, because if moisture is there, then the corrosion effect will be there, and then acid gases are present in the natural gas. So corrosion can be occurred. To eliminate that, dehydration processes are done. Some gases, those are harmful like H2S, they are also removed at the surface facilities through the process called the sweetening processes. And then we discuss in detail in week 6 about compressor design. So the natural gas need to be sent from one place to the other place. Natural gas is compressible flow. So by nature, the compressor should be designed properly to compress this natural gas from one point to the another point, and then the location or the distance between 2 compressor stations need to be estimated to make sure the pressure is enough to let this gas flow from point 1 to point 2 or the desired point. In week 7, we discuss about the measurement of the natural gas. So the value of the natural gas is of course based on its composition, based on its energy content. But when we are sending the natural gas to the users, we also need to measure it in terms of the volume, not only at the consumer end, at the production site also. Sometimes the sites are in remote locations. So the old technique as well as the new technique of the flow measurement of natural gas were discussed in week 7, along with very important concept of transportation of natural gas. to the desired location through different mode, like we are transporting by the tanker, by the pipeline, by converting gas into the liquid form, uh, GTL process, NGL process, and then other. In detail, we discuss about the transportation by the pipeline, several combination of the pipeline design like the parallel, series, and the loop combination, how the efficiency of the pipeline can be increased by designing the different combination of the pipeline design. In last week 8, we discussed some specific issues those occur when we are dealing with the natural gas, like the liquid loading, gas hydrate formation, and others. Along with these special we also discuss about the unconventional form of the natural gas. So far what we discuss is the conventional natural gas production, but the world is moving towards unconventional resources of the natural gas, like the tight gas, shale gas, gas hydrate, coal bed methane. Briefly in 2 lectures, we discuss about those type of the gases. And in lecture 25, that was the last lecture, the review of the entire syllabus was done in that lecture. So I already explained you again the entire syllabus that I designed for this MOOCs course and completed in 25 lectures. Now I'll see if there is any question. I'll take the question from the YouTube portal. These are just those equations and I did not see any question yet posted on the YouTube. So I'll take a pause for some time, wait till some questions are coming on YouTube, or if there is no question for next few minutes, then we will decide like should we continue or can we terminate. But I'll be still here for 10-15 minutes, of course, to get the question from you. Thank you. Yes, there is one question asked in the doc file by Mayuka. It was asked like how to solve the numerical problem of week 3 and week 5. Can you please teach in detail? So week 3 is about the IPR, inflow or organized relationship, along with the well testing. So what I tried to do in this slide itself, as we were not having this separate provision for the tutorials that time. So what I did, I solved the problem of IPR and well testing with example. If you follow the lecture video carefully, you will be able to solve at least one problem based on the IPR and one problem based on the well testing analysis. So IPR is about how flow rate is related to the pressure drawdown, and that is the relationship which have the properties of both reservoir rock as well as the fluid, that is the natural gas. So the mathematical equation was set up. At the final stage, the equations is including the properties of the rock as well as natural gas. So you should be knowing how to calculate those properties, and then using that equation, you can calculate the relationship between the, or you can develop the IPR equations. That IPR equation could have a different form depending on the pressure rating. If you remember in one of the chart, I discussed about the P approach, P square approach or MP approach should be considered depending on the pressure. So if you choosing appropriate approach, the examples given should be quite good help for solving the IPR related problem. What I'll do in the next live session, I'll come with some example and discuss with you. Similarly, for the week 5, where the separator designs was discussed, so we are having the two-phase separator, three-phase separator. Those could be the horizontal separator as well as vertical separator. I had given one example in this slide with the stepwise procedure, how different segment of the length of the vertical separator or for the horizontal separator, how the different height or the diameter, total diameter of the horizontal separator can be estimated, and based on the length to diameter ratio, we can decide the design is appropriate or not. I think I discussed in this slide with a quite detail, but as you mentioned, I'll try to come with some example in the next live session 2, with some example to explain it in more detail. Thank you for asking this question. Many students might be facing this problem because it's not only complex in nature, but the estimation of certain properties. For example, pseudo real gas pressure MP value for natural gas, it requires some mathematical skill also. So I'll see if I can bring with some example in the next live session. Thank you. Yes, I did not see any further questions. Then we can close this live session for today. We will meet a live session 2 in the next month. I hope you will come with your questions, and I'll try to answer those questions in that live session. Thank you very much for joining this MOOCs course. Thank you.